Thank you for your time. This interview will consist of two questions, and we will be spending 45 minutes to solve those two questions. Um,
Okay.
Let me just copy and paste the first one into the code share in a second.
Okay.
Let's put some comments here. Yeah.
Okay. Columns sequence in mathematics can be defined as follow. Starting with any positive integer. Okay. Positive integer like 3, for example. You're right. Write this thing here. If n is even, which means n 1 by 2 equals 0. If n is even, the next number in the sequence is n divided by 2. Okay. If n is odd, then the next number in the sequence is 3n plus 1, right? So, oops, 2.
Sorry, could you zoom in a little to your could you zoom in to your screen so the
Oh, yeah. I'm not sure. Maybe this. Oh, yeah. Oops. That's a lot.
there you go.
Is that okay? Better?
Yeah.
Okay. Sorry. So for this case, for example, is 3n plus 1, right? So in our example, it could be 3 multiplied 3 plus 1, so it's 7, right? In the example here, it could be the next one could be 1, thinking that just getting the integer part. So it is conjecture that every such sequence eventually reach the number 1. Okay, so that means that eventually you're gonna get number 1 after a finite number of time.
Yeah.
Okay, that's this conjecture. Bonus. Okay, what input n less or equal than 1 million? Yeah, 1 million gives the longest sequence. What input? Okay, what input n less equal 100? 100,
Focus
1 million.
on the main problem, and
All
then
right.
if we have time, we go into the problems.
All right, cool. Okay, so what I'm getting here is that our input is a simple string, correct?
Our input is sorry.
Well, in this case, it's an integer, right?
Yeah.
It's just an integer, right? For our example, is 3, correct? Example, right? But it could be any integer, right? And
Any positive integer.
any positive integer, correct? So what is exactly what we have to return in this function, or what do we have to get from as a result?
You just have to test it.
Okay, but it's just iterating through to get and at some point get number 1. That should be the final criteria to stop the
Yeah, I mean,
algorithm.
imagine you are creating unit tests for this conjecture.
Okay, got it. Okay. All right, so let's do it. So we have a function here. Can I copy this? Okay. Sequence. Okay. So what I'm going to do is, well, you want to test. So the instruction says that we eventually reach the number 1. So we're gonna return 1 at some point. Right? So okay. So for here, we're going to just get the number, but we have to create a variable, right? So an auxiliary equal to none. And what we have next is just maybe do a while auxiliary is not the 1. We're gonna do this this loop. By the way, about the input data, is there any restriction? For example, what happened if I just reach number 1? Should we return in that case?
Yeah. I mean, it's the inputs are positive integers, meaning that it's greater than 0. It's not going to be 0. So if we have 1, we return immediately. That's valid.
Okay. So now this 1, just return that. Okay. So for the rest of numbers, so what we're going to do is set a new value for the sequence. In this case, we really want to check what is oh well, maybe this is not necessary because we are already checking if it's number 1. So yeah, we can return immediately. Right. Okay. What else? So we have to check if auxiliary model 2 is equal to 0. In that case, we're going to get the integer part of a division, right? In this case, is auxiliary between 2, right? Otherwise, we're going to get 3 plus multiplied by auxiliary plus 1, right? So, okay. Well, that's basically it in terms of the main process. Let's test it out. So let's use our example 3, right? In our example, we're going to get first 3, right? So auxiliary is 3 now is not equal to 1, so we're going to iterate through this method. So the next value for auxiliary in this case, which is an odd number, would be 7, right? And the next one would be also an odd number, so we're going to multiply 7 and 3 and plus 1, so we're going to get 22, right? So 22 will give us in the next iteration divided by 2, 11. So in the next one, we're going to get 33 plus 1, 34. In the next one, we're going to get 17. In the next one, 73 plus 7, 21. 21 plus 30, 51, 52. Then the next one will be could be 26, right? 26. Then 26 again is 13. And 13 is 39 is 40. The next one is 20. Next one is 10. Oops, sorry, 10, 5. And 5 is 16. There you go. And we're gonna get 8. We're gonna get 4. We're gonna get 2, and we're gonna get 1. And that's it. Well, in this case, this value were for 3. Just checking if we got 1. Obviously, it could be obvious, but we got 1. In this case, auxiliary is 1, so we're gonna not check anything. So we draw 1, right? That's basically it with this, and any positive integer, correct? Okay. Now the bonus. What input n less or equal to 100 gives the longest sequence?
A million.
Okay. Okay. So in this case, we have to get the longest sequence provided by this number, right?
Yeah.
Okay. Okay, but at this case, I think it's totally well. It should be an additional problem, right? So we can recycle this, but I think I need to create another function in order to get that. So I think for this case, what we have to do could be well, one option is just test every possible input from 1 to 1 million and see well, and detect what is the longest one, right? But I'm not sure if could be necessary. I mean, checking one by one, because what I'm getting here is that in most of the cases. So for example, if we insert 80, we're going to get eventually this set of numbers, right? So plus 1, because we are counting the 81. So so what do you think? Do you like to well, sounds good to you if I just iterate at this point just from 1 to 1 million in order to get the longest sequence?
Probably gonna be too long. Yeah, don't worry about it. Let's do the next problem.
Okay.
Give me a second. Let me just need to paste the problem up here, and I'm going to copy this.
Okay, you can remove this. Okay. Given a singly linked list and an integer k, remove the k last element from the list. Okay, k is guaranteed to be. Okay, I'm gonna just add enough line here. K is guaranteed to be smaller than the length of the list. Okay, so if the list is n, has n value, so always a is less than the array. Well, array. list.count, for example. Right. Okay, the list is very long, so making more than one pass is probably expensive. Okay, do this in constant time and in one pass. Okay, it's a very, very, very long. Very long. Okay, when I read this again, given a single list, okay, is a single list and an integer. Okay, so I think from our function, oops, it's not working. We have a function. I don't know how to call it yet. We have a value k, right? And we have a linked list, right? So the point here is that remove the k last element from the list. So for example, if we receive 3, right, as k, and we have a list like this, 3, 2, 1, 3, 2, 4, 1, 5, for example. So we have, we are thinking the head like this is the first element, right? So the tail is this one because we are at the end. This is correct, right?
Yeah.
So in this case, well, I'm going to use instead of 3. Oh well, maybe add another value here. So remove the elements. So the idea should be remove this one, right? So because we're going to start counting from the last one to the first one, correct?
Sorry. So you want to remove the k to the last element. K last element. Okay. So which is the third one? You said 1, right? You said 1.
Yeah.
That's the first last element.
This is the last element, correct? So. So what I'm getting here is that we have to remove, in this case, the third last element from the list.
Yeah, third last element. That's correct.
So this is the, because this is the first last element, right? This is the second last element, and this is the third one, correct?
Correct.
Okay, got it. So space, remove. Correct. Okay. All right. Well, we know that the list is very long, right? So should be this algorithm should be in all the end because it's just one pass, and well, it's time and space. In terms of space, we are forced to use all one, right? Okay. So for this exercise, I assume it's obvious the k value is just an integer, but for the case of the linked list has parameter, should I use the head node as the entry point, or yeah, is that okay?
Yeah.
Okay. Okay, I'm going to use, and I'm going to invent something like this, right? No. Right. And in this case, just to clarify, node contains the classic values, node, right, which is the val. I'm going to assume it's just in integer, and the next one could be another node, correct? class is a class because in Swift is a reference value. Okay. All right. So the point here is remove. Okay. So in order to do this action, should we need to remove? Should we need to return anything special? Because
value, like the one that you remove, let's return the integer value that is in that node.
I'm sorry. Could you repeat
For
that?
example, in the example that you have above,
Mhm.
you will return 1 because that's the one that you
Oh, okay. The remove element, correct. Okay.
Yeah.
So okay. So and what I'm as well seeing here is that we always gonna remove something, right?
Yeah.
Okay.
Correct.
So in this case, there's no. I mean, it's guaranteed to be a node here. So well, we're not going to use an optional here, right? Okay. All right, before moving forward, I want to explain more or less what idea I have in my mind for this. So obviously the easiest way to do it without any restriction and with a very small linked list like this is just well, starting from the head and then moving forward, right?
Yeah.
And well, at this point, for example, we will have to check how many elements we got in this list, right? So we only got the tail, so we have to count every next value we found, and once we got that number, in this case 6, for example, we're going just to check again against these numbers. So what we have to do is it's just counting. Okay, in this case we have total equals 6, and the numbers, the first number is 3. So we will have to get again the actual index to do that, which is k minus 1, because we are counting this as the, well, at this point we got the last element, right? So the total is 6. So for the purposes of this, oh, sorry, I think I'm wrong here.
So let me just stop you right there. So
Okay.
what you are saying is that we should count the elements first, right?
In a naive approach, yeah.
Okay, so if you read the problem, there's a line which says
Yeah. I know. Yeah. I'm talking about the naive solution, but I know that this is the.
Okay. Sorry.
I just was explaining what in a in a happy path with a brute force solution, something like this, right? Just I wanted to clarify my mind with that. So just returning to my example, there's no way to once we are in this element, we can go back, right? So the only way, the entry point is always the head, right? And well, we in our example, obviously I'm considering this, but I will go back in a minute. I'm going to add another element here, right? So in this case, we're gonna remove 5, right? So yeah. So that's my point. So in the naive approach, we have to read, okay, what is the counting number, the total elements, and in the to know exactly what is the row we have to remove. I think, well, actually we don't need the -1 because we just need this case. We just need to get that total minus k. In this case, will be 4, right? And when we are positioned at the position of the 4 node, we know that the next one will be the value to be removed, right? So the only thing we have to do in that case is point to the next one of the next one, in another way, pointing to 6, and then and that's it. No, it's just removing the next condition to this one from 5, and that's it. The node will be isolated, right? But that again, that's the naive solution, right? But again, we cannot do that. So I just wanted to clarify how to identify this. Okay. So thinking again that we cannot read this, what I'm going to do is probably could be a solution with two pointer approaches, for example, right? Because what we can do is one we're gonna move next by next in one pointer, another one moving two times faster, right? In that case, we could still reading the whole list, but also getting the total or reaching the total in the half of the time, and for that time we can figure out, for example, if yeah, sorry.
I was going to ask you that if you can tell me the time complexity of that approach that you told me. Like, okay, if I do it with one pointer, it will be O of n, right?
Mm-hmm.
And if I do it with 2 pointers, how will the time complexity change?
Well, what I'm getting here, again, that you mentioned, if we move one by one, is just O the n, O n. But if we sum the other pointer, could be n minus n divided by 2, right? Because we end the sequence in the half of time, right?
Yeah, but it's still O of n, right?
Mm-hmm, exactly. Mm-hmm. Yeah.
Okay.
Yeah. So okay. What I'm trying to figure out here is that some cases, because at this point, for example, in this particular example, with k equal 3 and a total value of 7, we know, well, because we can see it right now, that the key value is from this side of the linked list, right? The challenge here is figure out where is the position, how to position the value, because, for example, could be a case where we could remove the first elements here, for example, number 2, and we should take care that to not move the first pointer, the slow pointer, too fast to pass this one, because otherwise we're not going to be able to remove the node. So what I'm trying to do is I'm going to try this approach with this linked list and see if it's that work.
Yeah, go ahead.
Sounds good. Okay. Okay. First, what we have here. This one is move to next slow pointer.
I just have one question.
Sorry?
I just have a question. So you say that you first want to count how many elements are there with 2 pointers, right?
Mm-hmm. Yeah.
Then you're going to pass again?
No. No. Well, my point with the 2 pointers is trying to do it in one pass. Right?
Okay, so you have 2 pointers, and as I understand, one is going to move 2 times faster than the other one. So if I move one at one node each iteration, if I move one pointer, one node of each iteration, the other one I'll move 2 nodes each iteration. So at the end, I'm going to finish with one in the middle and one at the end, right?
Mm-hmm. Yeah.
Okay, so let's say that I have a list with 8 elements.
Mm-hmm.
I have a K of 7.
Mm-hmm. Okay. Yeah. In this case, yeah. That's my issue. Because we're gonna lose this.
Yeah, because
Oh, okay. I think I got it.
okay.
So the clue here is that the key, the K value is always what is guaranteed to be smaller than the length of the list.
Yeah.
Correct. So we never going to delete the head, right? So
Yeah.
yeah. So what we have to do is instead of moving twice, I'm going to move the pointer key times.
Okay.
Right? I'm just trying that, right? So for example, I'm going to use this example and this K, right? Okay. So the first one moves 3 to 2, right? But the other one, I'm going to move 1, 2, 3, 4, 5, 6, 7, right? So we're going to move 3 to 8, right? So obviously doing an iteration to do this, right? So at some point, obviously we're not in the next iteration, we shouldn't be able to move again, right? So we are positioned at 2, right? The only problem here is that there's no problem, because in this function we always have the head already. So yeah, just we need to check if where is the current position. If for this specific case, if we oh wait, just let me double check that. Other way we can do is instead of moving k elements, moving k plus 1, because the key is smaller obviously than the length of the array. So we know that the first movement we always contain elements, right? So if we detect, at this case, we're gonna end the list, right? So if we got that, we don't move then the next the slow pointer. So if we found null, we can then proceed to remove the node at the position of the slow pointer. So that makes sense?
Okay. Okay, you're going to. Can you repeat that again? Sorry.
Yeah. So, for example, going back to this example, we have A, right, and the K is 7. So we first move the faster value. So
Okay.
we're not. This is going to be number 2 in some case. So first move K plus 1 times the faster pointer, right? So for this example, we're going to pass from we're going to move 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. At this point, we found null, right? So the point here is that if null is found, then we know that the slope, how can I say it? The slow node dot next is the node to be removed.
Okay.
Okay. Otherwise, in the other case, else move slow pointer, right? Doing that all the time until we found that a null value in the faster node.
Okay.
Does that make sense?
Let's do k equals 3.
Okay, let's do it. All right, so let's do it. So faster, slower. So in this case, we're going to move 3 plus 1. So 1, 2, 3, 4. We are in 5, right? We're in 5. And the next one, well, at this point, is not null. Faster is still being valid. So we move 2. Right? So in the next iteration, we move k values, right? So 1, 2, 3, 4. Okay, we got null here. Okay. Well, yeah, slower is not the answer. However, 5 dot next is the answer.
5 dot next is it? Okay.
Okay. Okay. So.
But okay.
I don't know if just a coincidence.
It probably is a coincidence. So let's do a list that has 10 elements. How about that? And let's say k. Let's do k equals 3 as well. K equals 3. Yeah.
Okay. Okay. Again, we're gonna move 4 times 1, 2, 3, 4. We're still 5.
Mm-hmm.
By the way, we know that in this case 8 is the answer, right?
Yeah.
So slower is moved to right here. Okay. So 5 is again moved 4. 1, 2, 3, 4. Now it's 9. And slower is moved to 4. Yeah, here we found null. We cannot move anymore.
Mm-hmm.
Yeah, we not got the solution. Okay, what is wrong here? I mean, definitely. I think we should move in this way with some 2 pointers.
Yeah, I mean
Because it's the only way to avoid.
that's a helpful approach. It's just the way that we iterate those pointers that has problems, right?
Yeah. So let's try that again. So for example, if we move, I'm going instead of K1, I'm just I'm going to try the K times value again. Or no. Maybe there is. Maybe we should move the slow pointer a bit faster, not just one. But I'm thinking the way to do it. I will try again. So with the same approach, just I want to check something. So it's 1, 2, 3, 4. So it's again 5, and there is no issues here. So that's instead of slower. Maybe move K times, just for this case. I'm just trying something. Okay. 1, 2, 3. Going to move 1. So next one is 1, 2, 3, 4. It's 9. And this one is 1, 2, 3, 7. And okay, next is not valid because sorry. Sorry, because we we cannot move for K plus 1 times. However, in this case, slower is moving. Well, at this position, we know that the value is 8 to be removed, right? I'm going to do another test just to make sure that this is not a coincidence. Okay, so I'm going to use fast K equal 4 in this case. So in this case, I'm going to move 5 times. 1, 2, 3, 4, 5. In this case, is 6. And this one is 5. And then move again 5, sorry. 1, 2, 3, 4, 5. Oops, we end. And 1, 2, 3, 4. Yeah, in this case, 7 is the value, right? Is the value to be removed, right?
So what you're doing is moving each time you're moving one step less than the faster pointer.
Correct. My approach with the faster is moving K plus 1.
So
and the other one is just K times.
Where will the slower pointer be? at the end each time? I mean, for example, if the list is 10 elements and we have 4 uh, escape, you the slower pointer ends where? Because at the end of the day, we are using 2 pointers. One will find the end of the list, right?
Mm-hmm.
And the
Mm-hmm.
other one will find where we should be deleting the element.
Correct. Mm-hmm.
Huh?
Yeah. Yeah. That's the approach I try to follow.
Okay.
Okay. Uh, well, I try a lot. K plus one. I'm not sure. Is that okay for you if I try with K, only K times for the faster?
Uh, okay. I mean, we are almost out of time, so if you have anything that you can code, that will be great.
Okay. Okay. The point is that it's not, well, the answer is still not valid here. So I want to do one more test here. For this case is 1, 2, 3, 4, 5. And the other one is should be 1. And next one is 1, 2, 3, 4, 9. No, we ended when there's no also option here. So uh, there is something. Let me just check again here because maybe the remaining parts could help me.
Okay.
1, 2, 3, 4, 5, 6. And then the other is 5. So at this point we are 2 pointers ahead.
Mhm. So.
Oh, okay. I forgot something. Yeah. Since the faster will end first,
Mhm.
we can calculate the total, right? So I think the only thing is just checking how many steps we are ahead, we are behind of our target. So, for example, if we want to uh, uh, move this guy here, we're gonna get null, right? The null value, right? But at the end, we have to we will have the total 10, right?
Yeah.
So so the thing is just, well, uh, getting the index in this case, which will be with this formula, with this will be total 10 minus k equal 6. So in order to remove the items, just we need to move one time.
But okay, let's say case 9.
Okay.
Right?
All right. For case 9, oops, this is 10. Well, the index in this case will be 1, so will be this one. So let's do it. Let's do it. So 1, 2, 3, 4. So at this point, we got null, and we got the total, which is 10. And also we got we haven't moved the position of the slower, so but we know that we just need to move one position at the index 1. So in this case, we started 3, just we need to move one time. Well, actually, we don't need to move it, right? Because we are already pointer behind of that target. So you just remove the action, okay? So what I'm going to do here to do these things quickly is going to implement algorithm as fast as I can. I think, yeah, I got the answer. So, but total 0. So let's do faster note. More lower. Now here we're going to iterate through well, I'm going to use a 4 here in this case. No, sorry, no, it's a web. It's okay. After new. That's my point here. Again, okay, one element. So yeah, that way I want to use a 4 in order to get the k values. So 0 to k. And by default, it's just moving, well, faster equal to half, lower equal to half, faster is equal faster, but faster. Nice, going to do this faster. Right. So what I'm going to do here is it's moving in iteration. So I'm going to create a function that move k change node.
You can leave that. You can leave implementation.
Okay.
Yes.
Okay, I'm just going to copy in this. The point here, oops. Okay. So what we have to do in this implementation is just move position. I'm going to move k plus 1, the faster node, right? And but also I'm going to get value. So we're going to do this while faster is not node in this case.
Okay.
Right? And well, we also going to calculate through using in-out properties the total. So I'm going to right. So we got this. We got also total, right? And once and also we well, I'm not going to I'm not going to move slower actually, because we don't need to do that, because what we need is actually, well, is the formula. So that index is equal to total minus k. Well, right. So this is actually the value that we care, and then we iterate for int 0. Oops. And I'm going to move lower equals lower dot next. And once we do that, we want to have another function remove. So
just I just wanted to point out that what you're doing there is basically like going through the list 2 times, but with 2 pointers, right? Because you are not moving index, I mean, the slower at the same time as faster. So,
oh yeah, you're right. Okay. Okay, you got it. I wanna leave here. Yeah, correct. I just forget that. Okay. What we can do is checking right now here if faster is from nil, lower is equal move position k plus k. Although, well, we actually we could do the same here. Move is lower here, yeah, because it's just one pass instead of two.
I mean, you can do that, but I mean, the function will be like you will want a function to be independent of those variables, right? The function is move position, so you just pass the node and move that node. You can just do one though. That's what I mean.
Okay, but this approach sounds good to you, or?
I mean, yeah. You move the faster one and the slower one, but they end up um, apart from each other. When you detect null in faster, you calculate some kind of offset, right? And then when you
Correct.
lower that offset, okay. If you could just comment that below, that will be enough because we actually ran out of time.
Okay. What do you need to know? Sorry.
Yeah, just do like write what are the next step, like calculate offset.
Oh yeah.
Lower, and all that.
So, yeah, the point here is well, we have to do pointers. We iterate like we saw in the examples above. We move this one k plus 1, and this one k positions behind, right? Sorry, one position behind the faster, right? And only if we got if faster is still being not null, right? So once we got faster in, well, I'm running out of time, but the idea was to calculate also the total in this same function. So once we got the total, the only thing we know is we have to get, well, it's not an index, but it's just a way to identify this, right?
Okay.
So we calculate total minus k. So in order like this, for example, we're gonna get what is exactly the position of the item that we should remove, right, Ashley? So in order to know that, we can we have to double check that, but the point I think is probably we have to identify what is the lower position, right? So if we index is 5 and we are in the lower at the third node from first one to last one, I will have to move it one position, so be behind of the actual target to be removed. So once we got that, we implement a remote node, which is basically just connecting a slower node with the next of the target.
Okay.
And that's basically should be it.
Good. Do you have any questions for me?
No, thank you. I think your instructions follow me pretty cool on these exercises. So
all right.
So yeah.
So much
no more questions.
I'm gonna stop recording now.
Okay, thank you.